we're going to try a past paper type question. All right. Let's go through this question. I already drew up the graph. I personally would never attempt a kinematics question without a graph in front of me. All right. So here's how the question goes. Here's a goblin, and he accelerates from a point A at 1 meter per second squared from rest for 50 seconds. So that means the goblin starts from rest. You notice my y-axis is in meters per second. It's representing velocity. And my x-axis is representing time. But I'm going to be using seconds. And that's going to be really important. So the goblin starts from rest. Of course, if he accelerates, his velocity is supposed to increase. But this acceleration is applied for only 50 seconds. So 50 seconds will be somewhere here, midway between the 0 and 100. So at 50 seconds, he will have a different velocity. How do we calculate that velocity? Well, let's use the first formula. The initial velocity is 0 because the goblin is starting from rest. And his acceleration is 1. It's given in the question here. And he applies that acceleration for 50 seconds. So let's calculate the velocity he attains. V is equal to u plus at. The final velocity is what we're trying to find. Initial velocity is 0, the acceleration is 1, and the time is 50. Obviously, when we work this out, we're going to get 0 plus 50, which is 50 meters per second. So after the first 50 seconds, he attains a velocity of 50. So the graph will look like this so far. He starts off at rest, and after 50 seconds, his velocity is 50 meters per second. This 50 and this 50 are really not related. They're coincidence. It's a coincidence they are the same number. All right? All right. So from this point now read the question. Once it attains this velocity, it then moves at this velocity for 2 minutes. 2 minutes. I'm not working with minutes, I'm working with seconds. So 2 minutes is really 60 seconds because 2 minutes is really 120 seconds because 2 multiplied by 60. Now, from this point, he moves. From this point, 2 minutes are counted. So where would he reach? He's already at 50 seconds. So 2 minutes later, if you add 50 to the 2 minutes, could be 170 seconds. So 170 will be a little before the 200. So remember, this line is going to be a flat line because, read it properly, it then moves at this velocity for 2 minutes. So when he attained 50 meters per second, he kept that velocity. You notice the line doesn't get higher or lower. He kept that velocity for 120 more seconds, bringing him to 170 seconds. I'm going to just draw a dotted line here so it will be easier to see. Right? And this line here, bringing it down so it's a little bit easier to see. All right. Let's read the last part of the question. The goblin then decides to come to rest 150 seconds later at a point B. All right, so he's at 170 seconds. 150 seconds would be 170. That would be 320 seconds. So at 320 seconds, he comes to rest. So his velocity decreases to 0. The beginning point is A and the end point is B according to the question. This is my velocity time graph for this particular situation. So I drew my graph and now I'm going to start answering the questions. I have to find the distance between A and B. Like, what's the total distance? Remember, in a velocity time graph, if I were to find the area underneath the whole graph, I would get the total distance. So there are two ways you can do this. I can find the distance here using this form, using the green formula, the distance here using the green formula, the distance here using the green formula, and then add it up. Or I can take the easier approach and just find the area underneath each section, because finding the area of a triangle is really easy. Finding the area of a rectangle is really easy, and a triangle is also easy. So I'm going to take the easy way out. Let's find the area between, but I need to probably give these points name. I'll call here X and I'll call this point Y. Find the area between A and X. Well, it's a triangle. It's base by height divided by 2. The base is 50. The height is 50. And we're going to divide it by 2. 50 multiplied by 50 divided by 2 is 1250. So between here and here is 1250 meters. Right? Let's find the area of this rectangle. Remember, the area of a rectangle is length by breadth. The rectangle starts at 50 and ends at 170. So it's 170 minus 50. That's the length. And the breadth, well, from here to here is 50. You've seen it? 50. Let's add that up. Multiply. 120 multiplied by 50 is 6,000 meters. So this portion is 6,000 meters. And this one here again, right? I need to move this aside. Is a triangle, base by height divided by 2. It starts at 170, it ends at 320. So 320 minus 170 is 150. The base is 150. The height is still 50. And we have to divide it by 2. I am getting 3750. Alright, so just double checking that. 150 multiplied by 50 divided by 2. Yep, seems about correct. So how much is my total distance traveled? Okay. My answer for part A, the total distance traveled would be 1250 plus 6,000 plus 3750. The total distance traveled is, where can I put this answer? I was going to put, so we can keep track of it, I'm going to put a D with a small t here. It's going to be 11,000 meters. Right, just to keep track of our answers. That's the answer for part A. Alright. Okay, find the retardation of the goblin. Now, what does that mean? A retardation is just the opposite of an acceleration. So in a velocity time graph, the gradient will give us the acceleration. Now here the acceleration will be positive, because when the line slopes upwards, you get a positive number. And when a line slopes downwards, you get a negative gradient. So when they ask us the retardation of the goblin, they're talking about this part here. The part with the negative acceleration. So how do we find the retardation or the negative acceleration? We just find the gradient of that line, right? So we need 2 points on the line. Point, well, put this around here. This point here is 170, 50. And this point here is 320, 0. Alright? So let's move this aside to make some space. I'm going to call this x1, y1, x2, and y2. So it's y2 minus y1. That's how you find gradient. This should be basic by now. y2 minus y1, 0 minus 50 divided by x2 minus x1. 320 minus 170. So we're going to get 0 minus 50 is minus 50. And 320 minus 170 is 150. We're going to get negative 1/3 meters per second squared. So the acceleration is negative 1/3. Now this is a real tricky question. They ask you to find the retardation. Whenever they say retardation, it automatically means it's already negative. If they had asked you for the acceleration, the answer would be minus 1/3. But if they ask you for the deceleration or the retardation, they're already trying to say it's already negative. So you only have to state 1/3. So the acceleration from here to here is minus 1/3 meters per second squared. But the retardation is positive 1/3 meters per second squared. All right? All right. So that's part B. Part C, the average speed. Well, this is going to be really easy. Average speed is total distance over total time. So, move this around. Total distance is 11,000. Total time is 320 seconds. Let's just divide that. 11 divided by 320. We got 34.375 meters per second. That's the average speed of the goblet. All right? All right. So the last part is going to be a little challenging. Find the time it takes to cover 1/4 of the distance. All right? Now here's what. Before I actually do part D, I'm just going to calculate the acceleration for this portion by finding the gradient and the acceleration for this portion. Right? This point here, well, is 50, 50, and well, point A is 0, 0. If we were to find the gradient of a flat line, we're going to get 0. So the acceleration here is 0 meters per second squared. And then what the examiner told us, the acceleration for the first part of the question is 1. But if you were to find the gradient between 0 and x, I guarantee you would get back 1 in any case. All right. That's a slash there, by the way. All right. Part D. Let me see how best I can explain this. The total distance is 11,000. How much is a quarter of 11,000? So 11,000 divided by 4. A quarter is 227.50 meters. Right. We know from here to here is already 1250 meters. So let's minus 1250 from that. And we will get 1500. Which means we don't need this entire area. Because this entire area is 6,000. We only need, the orange part here just needs to be 1500 meters. So when we add it to the 1250, we will get quarter of the distance. All right? So we don't know at what time this happens. At what time will this happen to make the orange area 1500 meters? Right. How do you find the area of a rectangle? The area of a rectangle is just length by breadth. And we need that area to be equal to 1500. Well, the length is from here to here. How do we find the distance in between? And we have to take this t is from the 0. So between here and here, the distance is just simply t minus 50. That will give us the distance from here to here. And the breadth is 50. All right? Right? So, right, I hope you understand how I got here. Because if here was 70, to get from here to here, we'll have to minus the 70 from the 50. But instead of 70, we have a t. So it's t minus the 50. So all we have to do now is just simply solve for t. Right? We can throw across the multiply by 50 to get divide. and then we add the 50. So that's simple transposing. You guys are AdMath students. It shouldn't be too hard. So when we divide this and this, we will get divided by 50. We will get 30. And then we have to throw across the minus 50. That's this guy to get positive 50. We will get 80 seconds. So T is actually 80 seconds. So at 80 seconds, the total distance would be quarter. Sorry, at T seconds, the distance would be quarter of the full distance, which is 11,000. All right, guys. So I really hope that you understood this question. And stay tuned because I'll be doing another question in a few seconds. All right. Welcome to my second question, second past paper type question on kinematics. All right, so give the question a read, right? I already drew up an X and a Y axis for the question. So what it says here, there's a truck at a point A. So I'm going to call point A the beginning of the graph, starting from rest. So if it's starting from rest, that means its initial velocity would be 0 meters per second. So that's a dead giveaway there. Then it accelerates at a constant value. So the examiner was really nice to give you the acceleration value, right? And after this acceleration was applied, it attained a velocity of 24, which makes sense. If you take something that is not moving and you give it an acceleration, then its velocity is supposed to increase. So its final velocity is 24 meters per second. My only problem is that I don't know how long this took. So for me to draw this, I know it started at 0, and over a certain period of time, the velocity increased to 24. I just don't know how long it took. But that should be really easy to overcome. We can just use the first formula. We have V, we have U, and we have A. We can just calculate T. So using that formula, V is equal to U plus AT. The velocity, the final velocity is 24. The starting velocity is 0. The acceleration is 6, and we're trying to find the time. The 0 is going to amount to nothing. Throw across the multiply, you're going to get a divide. So the time will be 4 seconds. So in 4 seconds, I'm going to draw it in here one time. In 4 seconds, it was able to attain a velocity of 24 meters per second. Let's read the next part of the question. The truck then maintains this velocity of 24 for the next 8 seconds. So if it's at 4, another 8 seconds will take it to 12. Right? So it's going to be above the 12 here. Before, the truck then maintains its velocity for 8 seconds before decelerating to rest at 2 meters per second squared. All right, so let's see what's going to happen there. I really hope my graph is big enough to accommodate this. All right, so it goes from here to rest. The problem is I don't know how long it takes to go to rest. So I think I'm going to have to use this formula again, right? But this time we're starting here. So let's see if we can alter these values. So if we can figure out which values need to go here. We're going to use back this. V is equal to U plus A by T. Its initial velocity, remember, from this point it goes to rest. So its starting velocity is 24. Right? Its final velocity is supposed to be 0. Its acceleration, well, actually they said it decelerating before decelerating to rest at 2 meters per second squared. But that is a deceleration. So that means the acceleration is actually -2. Let's solve for t. This should be really easy. You're just going to throw across positive 24 to get minus 24 and then divide by -2. We're going to get 12 seconds. So it's going to take 12 seconds to go to rest. I'm lucky I drew this perfect. If we're at 12 seconds, then after a next 12 seconds will bring us to 24. So that's the sketch there for that particular, for the first part there. Determine the total distance traveled by the truck. Well, what we can do is just divide this up into 3 pieces. Let me just divide it up into 3 pieces here. Right? Right? And then you find the area here, here, and here. Or if you want, I know there's actually an easier way. Instead of adding up all 3 pieces, you realize this is a trapezium and these 2 sides are parallel. So we can actually use the formula for the area of a trapezium, which I'm getting here. I have it right here. Is half the sum of the parallel sides multiplied by the height. So let's use this formula. A half multiplied by the sum of the parallel sides. Well, from here to here is 24, and from here to here is 8, right? Because it's going from 4 to 12. So here's 8, and here's 24. If we add 8 and 24, we are going to get 32. And the vertical height is this, which is 24. Right? You see it? From here to here is 24. So if we were to find, instead of finding here, here, and here, let's just do it separately. So it's a half multiplied by 32 multiplied by 24. The total distance traveled by the truck, so the total distance, I'll put TD here, is 384 meters. All right. Now, I'm still going to do it piece by piece to prove to you that we will get the same answer, but I'm just going to do it quickly. I'll use a red ink here. Base by height divided by 2. The base is 4. The vertical height is 24 divided by 2. 4 multiplied by 24 divided by 2. This piece is 48 meters. Over here is just length by breadth. From here to here is 8 because it goes from 4 to 12, and the breadth is 24. So it's 8 by 24 is 192 meters. So I'm going to write it on top here. 192 meters. And from here to here is 12 because it goes from 12 to 24. So the base of the triangle is 12. The vertical height is 24. So it's base by height divided by 2. So 12 multiplied by 24 divided by 2 is 144. Let's add it up. 48 plus 192 plus 144. We got the same exact answer, 384. All right. Let's try the, another part, part B. Now there's a next truck, right? I'm just going to erase this 48 here. I'm just going to put an arrow here. So you remember it's 48. So the triangle is 48. So there's a next truck moving at 32 meters per second squared. All right. There's going to be a little problem. I need to move back this 48 down here. Well, you know this axis here is velocity. So I'm just going to erase that. And I'm just going to put this up. That's drawn to scale, but over here is going to be 32 meters per second. Right. So it races, so our next truck races past point A 3 seconds after the first truck has left point A. Calculate at what time will the 2 trucks meet. 2 items can only meet when they have the same amount of displacement. Only after they have the same amount of displacement, they will be side by side next to each other. Does that make sense? But let's see what's going to happen here. We want to draw this situation on the same graph. So remember, 3 seconds after the first truck pulled off. So let's see how this is going to be. At 0 seconds, there was no sign of the second truck. After the first second, there was no sign of the first truck. At the second, that sounds weird, there was no sign of the first truck. But on the 3rd second, that truck mysteriously appeared. So I was going to write in the 3 here. This is supposed to represent the 3rd second. At the 3rd second, a truck mysteriously appears. And it doesn't start from rest, you know. It starts at 32 meters per second. And it races, maintaining that velocity. All right. So that's this 48 is causing a problem. I'm going to draw this down here. All right. So this 48 was for the triangle. Okay. We need, at some point in time, right? At some point in time, the 2 trucks will meet. Calculate at what time will those 2 trucks meet. Now, I left out a piece of the question, but we had to assume that the 2 trucks met somewhere between the 4th and 12th second. So at a certain time between here and here, right? I don't know exactly where, at some time T, the 2 trucks met. But they actually stated that in the question. I'm really sorry I didn't print it out there. Right? So that means, this is a really bad rectangle. Let me try to draw back that right. Is the angle I'm sitting at, to be honest. Okay, that's supposed to be a rectangle. So that means the area between, the area underneath a graph gives us the displacement. So that means the area of the black portion up to here is supposed to be equal to the area of the red portion for the displacement to be equal. All right? So for the black portion, well, for the first truck, I'll call it the first truck. I'll color code it as I do it, right? From here to here is already 48 meters. This triangle. For this rectangle, the length is what? Well, here's T and here's 4. To find the distance from here to here, the length, we need to minus it. So it's T minus 4. Length by breadth. And the breadth there is 24. So that's the area of the black portion up to here. For the other one, the second truck, right? The area, well, if here's 3, it's length by breadth. The length is T minus 3, because if here's T and here's 3, to find the piece in between is T minus 3. Length by, and the breadth is 32. Right. For the second truck and the first truck to meet, the displacement of each truck must be the same, which means the expressions for the area must be the same. So guess what I'm going to do? I'm just going to take this expression and put it equal to that expression and solve it. So the first truck is 48 plus T minus 4 by 24. And this is supposed to be equal to T minus 3 by 32. Alright, so I'm just going to multiply all the brackets quickly. That's a bad choice. Here's 48. Everyone in this bracket gets multiplied by 24. T by 24 is 24T. Minus 4 multiplied by 24 is minus 96. And this is going to be equal to T by 32 is 32T. And minus 3 by 32, yes, is minus 96. So lucky for us, we got 96 on both sides. So that means when we throw across the 96 on this side, we'll cancel out with the 96 on that side, right? And let's double check it. 4 by 24 is 96 and 3 by 32, 96. So that means this and this will cancel out for sure. So we have 48 is equal to, throw across the positive 24, we get minus 24. So we get 48 is equal to 32 minus 24. 32 minus 24. It's 8. Throw across the multiply, we're going to get a divide. 48 divided by 8 is 6. So that means t is 6. So at 6 seconds, the trucks will meet or collide or crash into each other. I'm not too sure. All I know for sure is at 6 seconds, both of them will be the same distance from the starting point. All right. So I really hope that this question made sense. And the next set of kinematic questions actually deal with integration and differentiation. So you probably need to watch those videos first, right? So don't forget, you can find all my videos on www.iLoveLessons.com, right? When you go to the website in the menu bar, you will see free maths videos and free add maths videos. Click on whichever one you're doing and scroll down. And of course, if you're from Trinidad and Tobago and you want to have extra lessons in almost any subject, you can call me on 712-2652. We're located in Cunupia, and we have many subjects to choose from and a really, really good staff. So give us a call, right? If you're interested. Take care, guys, until my next video.